In this session, let us solve a few questions based on matrices. So far, we have dealt with matrix addition, matrix subtraction, multiplication of a matrix with a scalar value, as well as equality of matrices. So let's go through the first question. Construct a 2 by 3 matrix whose element aij is given by I minus j. So if we remember the notation, aij basically means, so aij means the element in the ith row, element of the ith row and jth column, element of the ith row and jth column, right? So now we want a matrix whose order is 2 by 3. 2 by 3 matrix would mean that there are going to be 2 rows and 3 columns. So let us construct that matrix. There are going to be 2 rows and 3 columns, right? So let us mark this element as A11. That's the element in the first row, first column. This is going to be first row, second column, and this is first row, third column. The matrix here would be element in the second row, first column, element in the second row, second column, and element in the second row, third column, right? These would be the elements of this matrix. Let us now find A11. So when I say A11, it means my I is 1, and J is also 1, right? So now the formula given is aij is equal to I minus j. So let's do one thing. Let us write that formula right over here, and then let's start substituting the different values of I and j. So I have aij is equal to I minus j. Let us now substitute I as 1 and j also as 1. So A11 becomes, I have substituted I as 1 and j as 1. So it's going to become 1 minus 1, which is equal to 0. Therefore, the first row, first column element is a 0. So let's fill up the matrix immediately. Now let's find A12. So let me write the formula for aij again. The formula for aij in this problem is given as aij is equal to I minus j. Now I'm trying to find A12. So let me replace my I by 1, right? And the value of j by 2. So when I do that on the left hand side, I should also do it on the right hand side. So I would be 1 and j is going to be 2, right? So this is going to be 1 minus 2, which is equal to minus 1, which means A12, the element in the first row, second column, is minus 1. So we have noted that down. Now let's go to A13. So A13 would mean instead of j being 2, now j should be equal to 3. So the value will therefore be 1 minus 3. That's going to be minus 2. And therefore the first row, third column element is going to be minus 2. Now let's find A21. So when I want to find A21, let us again write the formula for aij is equal to I minus j. So A21 would mean substitute I as 2. So let's substitute the value of I as 2 and the value of j as 1. So A21 therefore is going to be 2 minus 1, which is equal to 1. Therefore the value of A21 is 1, right? So this element is 1. Now let's find A22. So that's the value for j. So A22 will be 2 minus 2 and 2 minus 2 is therefore 0, right? Therefore the element in second row, second column is 0. So this element is 0. And now let's find A23. So A23 means the element in the second row and third column. So A23 is 2 minus 3, which is equal to minus 1. Therefore, the value of the second row, third column is minus 1. So this is how we construct the matrix whose elements are given by the formula given above, where aij is I minus j. Now similarly, let us also construct the matrix. Let's look at the second question. Construct a matrix of order 2 by 3. So again, 2 by 3 means my matrix is going to have 2 rows and 3 columns. Let's mark it. A11, that's first row, first column. A12 would be first row, second column. A13 would be first row, third column. A21 is second row, first column. A22 is second row, second column. And A23 is second row, third column. So now I know that Aij is equal to 2i plus j, the whole divided by 3. So let me find A11. When I am finding A11, it means I have to substitute I as 1 and j also as 1. So that means this is 2 times 1 plus 1 divided by 3. So that's 2 plus 1, 3 by 3 is 1. Therefore, the first element, first row, first column element, which is A11, is given by 1. Right? This element is 1. Then I have A12. A12 is given by 2 times I, that's 2 times 1, plus j is 2 divided by 3. So this is going to be 4 by 3. So the first row, second column element is going to be 4 upon 3. And this happened because I was 1 and j was 2. That is what I substituted in this particular formula to get my A12. Now let me find A13. So when I'm going to find A13, I'm going to multiply the first entry by 2. So that's 2 times 1 plus j is 3, the whole divided by 3. So 2 plus 3 is 5. So this becomes 5 by 3. So the first row, third column element is given by 5 upon 3. So this is 5 by 3. Now let's find A21. So A21 will be given by 2 times I, that's 2 times 2, plus j is 1 over here divided by 3. That's 4 plus 1. 4 plus 1 is 5. So 5 by 3. So my A21 is also 5 by 3. Let's find A22 now. So to find A22, I should substitute I as 2 and j also as 2. So it becomes 2 times 2 plus 2 divided by 3. That's 6 by 3, which is equal to 2. So the second row, second column element is also 2. So let's note that down. This is 2. And now let's find A23, which is going to be 2 times I, that's 2 times 2, plus j is 3 divided by 3. So 4 plus 3 is 7. So this is basically 7 by 3. So I noticed that I was able to find all the elements by substituting the appropriate values for I and j. And that is how I was able to construct this particular matrix. So let me pause for a couple of seconds and then we will continue with our next question. One key point to remember in these two problems was the notation. The notation is very important. Again, let me repeat it. Aij means the element in the ith row and the jth column. Rows are always horizontal while the columns are vertical. So if you want to locate A31, it would mean the third row and the first column. So by substituting different values for I and j, you can actually find all the elements in your matrices. So let me again pause for a few seconds and then we will continue. Okay, let's move on to the next one. Consider the following question. If the matrix which is given on the left side is equal to the matrix on the right side, find the values of A, B, C and D. Because these two matrices are equal, their corresponding elements have to be equal. So let's note down that as an important reason. Because the matrices are equal, their corresponding elements have to be equal, right? This was the definition of equality of matrices. Therefore, the first row first column element, which is 2, is equal to the first row first column element, which is C. So I got the value of C. The first row second column element on the first matrix, which is A minus 1. So A minus 1 should be equal to the first row second column element of the second matrix. So A minus 1 should be 4, which implies A has to be equal to 5. The second row first column element on the left hand side, which is B, should be equal to 3, and the second row second column element on the left side, which is minus 6, should be equal to 5D minus 16, right? Because they are the corresponding elements. Therefore, 16 minus 6 is equal to 5D, which implies D is equal to 2. So this is how we get the value of A, B, C and D. The concept used in this particular problem was, if two matrices are equal, then their corresponding elements have to be equal. So let me pause for a few seconds and then we will move on to our next question. Okay, moving on to the next one. Yes, let's take a look at this question now. Again, two matrices are equal. So we know that if two matrices are equal, then their corresponding elements have to be equal. So now let us take the corresponding elements. X square minus 3 should be equal to 6. Therefore, x square minus 3 is equal to 6, which implies x square should be equal to 9. And therefore, I can say that x is equal to plus or minus 3, because square root of 9 could either be positive or it could be negative. And therefore, the value of x is plus or minus 3. Let's now compare the next element. So 2y should be equal to 8. So 2y equal to 8 would imply y is equal to 4, right? So that's the value of y. Let's compare the next element, 3z. 3z has to be equal to 15, which implies z has to be equal to 5. And therefore, the value of x is plus or minus 3, the value of y is 4, and the value of z is 5. So we use the basic concepts of linear equations and quadratic equations, as well as the concept of equality of matrices to solve this particular question. Let me again pause for a few seconds and move on to the next one. Okay, moving on to the next one. Yes, let's consider this question. Again, this question involves equality of matrices. Solve for A, B, X and Y if these two matrices are equal. So again, if two matrices are equal, then their corresponding elements have to be equal, right? Have to be equal. So let us take a look at their corresponding elements. 2x plus 3y should be equal to 3. Then look at this particular equation. This is the second row, second column. Now why am I picking this particular equation? Because I noticed that my first equation is in terms of x and y. So I started looking for another equation which is in terms of x and y. I noticed that I have 3x minus y, which is the second row, second column element, that should be equal to 10. So now if I solve these two equations simultaneously, I should be able to find the value of x and y. Similarly, let's take a look at the next corresponding elements. A minus 2b should be equal to 8. So a minus 2b is equal to 8 and 2a plus b is equal to 6. So 2a plus b is equal to 6. So now again, if I take this particular set of simultaneous equations and I solve for a and b, I will get all the four variables. So let me now quickly solve for x and y. I wish to eliminate y. So let me multiply the second equation by 3. So I have 2x plus 3y is equal to 3. And multiplying the second equation by 3, I get 9x minus 3y is equal to 30. When I add these two equations, I get 11x is equal to 33, which implies x is equal to 3. Now I can substitute x as 3. Okay, so let's move this set of equations to the right side so that we get some space for solving the question. Okay. So now I will substitute x as 3. So substitute x as 3 in any of the equations, say in the first equation. So let me label these two equations. So in the first equation, when I substitute x as 3, I get 2 times 3 plus 3y is equal to 3, which means 3y is 3 minus 6, which means 3y is minus 3 and therefore y equals minus 1. So the value of x is 3, let me box it, and the value of y is minus 1. Now let's go ahead and solve for a and b again. So again, let me eliminate b. Let me multiply the second equation by 2. So I get a minus 2b is equal to 8 and 4a plus 2b is equal to 12. Let me add these two equations. So minus 2b plus 2b cancels. So I get 5a is equal to 20, which means a is equal to 4. Again, let me substitute a as 4. So substitute a as 4 in the first equation and I get 4 minus 2b is equal to 8, which means minus 2b is equal to 4 and therefore b is equal to minus 2. So we have got all the four variables, and if you now substitute these values of x, y, a and b in the left matrix given on the left hand side, you will get the values on the right hand side. You can try that, and this is how we solve for the values of the four variables. Let me pause for a few minutes. In the meanwhile, while I don't say anything and I pause for a few minutes, I'm just going to substitute the values of x, y, a and b here and show you that I get the right answer. So when I substitute the values of x, y, a and b, I notice that I got the matrix on the right side. Therefore, my solution seems right. Okay, let's move on to the next question now. So in this question, three matrices are given to me, A, B and C. I am supposed to find A plus B minus C. Okay, let's substitute now. So let me write the solution. So let us find A plus B minus C. Let's substitute the different matrices. A is 4, negative 2, 5 and 7. Plus B, B is 3, 5, negative 4, negative 1. Minus C, C is 1, 3, negative 2 and 4. Right? So now what I'm going to do is I'm going to add and subtract the corresponding elements. So I get 4 plus 3 minus 1. Then I get minus 2 plus 5 minus 3. 5 plus of minus 4, that's minus 4. And minus of minus 2. Please be very careful. In case you want to avoid making mistakes, I will show you how to do it. You can simply write or combine the elements in the first step. So 5 plus of minus 4 minus of minus 2 so that you don't make any mistakes. Then 7 plus of minus 1. So plus of minus 1 minus of 4. Right? And now we can evaluate the elements. 4 plus 3, 7 minus 1 is 6. Negative 2, positive 5 is 3 minus 3 is 0. This is going to be 3. And 7 minus 1 is 6 minus 2 is 4. 6 minus 4 is 2. Therefore, this is my final answer. So again, when you add and subtract matrices, make sure that the orders are the same. And add and subtract the corresponding elements. And be really careful with the signs. Yeah, that is going to be very important. So let me pause for a few seconds. Okay, let's take a look at these two questions now. I have matrix A and B given to me. I have to find 2A plus 5B. So let's find it. So let's write the solution. I want to find 2A plus 5B. So 2 times A is going to be 2 times 3, negative 4, 5, 6 plus 5 times B, which is negative 1, 2, 5 and 7. So let's find this value. 2 times 3 is 6, 2 times negative 4 is minus 8, 2 times 5 is 10 and 2 times 6 is 12. So we know that when we multiply a matrix with a scalar value, we have to multiply the scalar value with all the elements inside the matrix. Plus, let's multiply 5 with all the terms. So 5 into minus 1 is minus 5. 5 2s are 10. 5 5s are 25. And 5 7s are 35. And now we are going to add the corresponding elements. This becomes 6 plus of minus 5. 6 plus of minus 5. Minus 8 plus 10. Minus 8 plus 10. 10 plus 25. 10 plus 25. And 12 plus 35. So now let us simplify all the elements. 6 minus 5 is 1. negative 8 plus 10 is 2, 10 plus 25 is 35, and 12 plus 35 is 47. So this is my final answer. Similarly, in the next question, I have to find 5 times this matrix minus 1 by 3 times the second matrix. So again, this is multiplication of matrix with a scalar value. So let's multiply 5 with, so we have to multiply 5 times 3, 4, 2, minus 6, minus 1 by 3 times 12, negative 9, 6, and negative 12. So let's multiply 5 with all the elements inside. 5 3s are 15, 5 4s are 20, 5 2s are 10, and 5 into minus 6 is minus 30. Let me keep the negative sign as it is, and let me shift the 1/3 inside. So this is 1/3 of 12, this is 1/3 of negative 9, this is 1/3 of 6, and 1/3 of negative 12. So now let's evaluate this. That's going to be 15, 20, 10 minus 30 minus, now let's find what is 1/3 of 12. 1/3 of 12 is 4. 1/3 of negative 9 is minus 3. 1/3 of 6 is 2. And 1/3 of minus 12 is minus 4. Right? And now let's perform the subtraction. Be very careful. 15 minus 4 is 11. 20 minus of minus 3, that's 20 plus 3, which is 23. 10 minus 2 is 8. And minus 30 minus of minus 4, that is minus 30 plus 4 is minus 26. And this is my final answer. So in these two questions, I used multiplication of a matrix by a scalar and also some concepts of addition and subtraction of matrices. Okay, pausing for some time. Okay, moving on to the next one. Okay, consider the following question. If matrix A equals 2, 0, minus 3, 1 and matrix B equals minus 2, 4, 3, 1, find a matrix X such that 3A plus 4X is equal to 5B. So what comes to my mind now is, I know that generally when I solve equations, I always tend to isolate my variable on one side and keep the constant on all constants on the other side, or rather keep all the unknowns on one side and knowns on the other side. So here X is the only unknown. So I will write this as 4X equals 5B minus 3A, which means this equals 5 times B, that's 5 times negative 2, 4, 3, 1, minus 3 times A, so 3 times A is 3, 2, 0, negative 3, 1, and this is equal to 4X. So now let us evaluate the matrices. So 5 into negative 2 is negative 10, 5 4s are 20, 5 3s are 15, and 5 1s are 5, minus, let's multiply 3. By the way, I have kept the negative sign here, so that means I need to shift 3 inside for multiplication. So 3 2s are 6, 3 zeros are 0, 3 into minus 3 is minus 9, and 3 1s are 3. And now it's time to perform the subtraction. So 4x is therefore equal to, when I subtract, I have to subtract the corresponding elements. So 4x is equal to negative 10, negative 6, 20 minus 0. Then I have 15 minus of minus 9. Be very careful with the signs. And I have 5 minus 3, right? And therefore, what I get is 4x equals negative 10, negative 6 is negative 16. 15 plus 9 is 24. 20 and 2, right? And therefore, now this 4 is in multiplication. So on the other side, I'm going to send it to division. So it becomes 1/4 of negative 16, 24, 20 and 2. Let me multiply each element by 1/4, right? So negative 16 into 1 by 4 is negative 4. 20 into 1 by 4 is 5. 24 into 1 by 4 is 6 and 2 into 1 by 4 is half. So the matrix X is equal to negative 4, 5, 6 and half. The concepts that I used in this particular question was multiplication of a matrix by a scalar value and of course the subtraction of two matrices. So again, let me pause for a couple of seconds and then we will continue with the next question. Let's continue with our next question. So in this question, again, I have been given matrices A and B and I have to find the matrix X again. So X is the unknown over here. I have to find the matrix X such that A plus B is equal to 3x. So again, what I'm going to do is I'm going to keep the knowns on one side and unknowns on the other side. So if A plus B minus 3x is equal to 0, I can say that A plus B is equal to 3x, transposing the 3x to the other side. Let's take the matrices A and B. So 2, 3, 5 and negative 4 added to the matrix B, which is 10, 12, negative 17 and 19 is equal to 3 times x. So now I have to add the corresponding elements. 2 plus 10 is 12, 3 plus 12 is 15, 5 minus 17 is minus 12 and minus 4 plus 19 is 15. This equals 3 times x, which implies, so now that I have 3x, 3 is in multiplication with x, I can take it to the other side. So x will be 1/3 of 12, 15, negative 12 and 15. So if I multiply each element with 1/3, 1/3 of 12 is 4, 1/3 of 15 is 5, 1/3 of negative 12 is negative 4 and 1/3 of 15 is again 5. So the matrix X is equal to 4, 5, negative 4, 5. And again, we used concepts of addition and subtraction of matrices as well as multiplication of a scalar with a matrix, right? So let us now again pause for a couple of seconds and then we will continue. Okay, let's move on. Okay, take a look at this question. We have to find the values of x, y and z over here so that this equation holds true. So it is given that 3 times this matrix. So why don't we go ahead and start the multiplication process. So we have 3 times -1 would be -3. 3 times 4 is going to be 12. 3 times 2 is 6 and 3 times x is 3x. Plus I would have 4 times 2 is 8 and 4 times -3 is -12. 4 times -5 is -20 and 4 times 5 is 20. This is equal to, let's multiply 5 with all the elements. So I have 5y, I have 0, I have 5z and I have 50, right? So now I should add the corresponding elements of these two matrices. -3, +8 is 5 and 12 minus 12 is 0. Then I have 6 plus of -20. Now 6 plus of -20 becomes -14 and 3x plus 20 is the second row, second column entry. This equals 5y, 0, 5z and 50, right? So now I can say that if two matrices are equal, then the corresponding elements are equal. The corresponding elements are therefore equal. And therefore what I can say is 5 is equal to 5 times y. Of course 0 equals 0. I don't need that because there's no variable there. Then -14 is equal to 5z. -14 is equal to 5z. And I have 3x plus 20 is equal to 50. So I've equated all the corresponding elements. So I get y equals 1 from this. I get z is equal to -14 by 5 from this. And 3x plus 20 is 50 means 3x is 30, which implies that x is equal to 10. So I have got all the values of my variables using the concept of addition of matrices and equating two matrices. Let me just pause the video for a couple of seconds and then we will continue. Okay, moving on. Look at this particular question. Find matrices x and y so that x plus y is equal to 5, 2, 1, 3 and x minus y equals 1, -10, -5, 7. So I have to find two matrices which satisfy these two equations, and therefore I am thinking of using the concepts of simultaneous equations here. Though we have applied simultaneous equations to normal variables, please note that we can also apply it to matrices because they are the unknown terms that we have right now, and their orders are both going to be 2 by 2 because their addition is also a 2 by 2 matrix and subtraction also 2 by 2 matrix. So definitely adding them or subtracting these two equations shouldn't be a problem, right? So if I directly add these two equations, I get x plus x is equal to 2x and positive y, negative y cancels, is equal to, and now I will have to add these two matrices. So 5, 2, 1, 3, add this with 1, negative 10, negative 5 and 7. So when I add these two matrices, I get 5 plus 1 is 6, 2 plus of minus 10, that's 2 minus 10 is minus 8, 1 plus of minus 5, that's minus 4, and 3 plus 7 is 10, which means the matrix X equals, now 2 is in multiplication, so on the other side it goes down to division, so it becomes half of 6 minus 8, negative 4 and 10, and half of this is going to become 3, negative 4, negative 2 and 5, right? So the matrix X is therefore equal to 3, negative 4, negative 2, 5. Now what I can do is I can substitute the matrix X in either of the two equations. So let me mark this as equation 1 and this as equation 2. So I'll substitute it in the first equation. So I have X is 3, negative 4, negative 2 and 5 is equal to, plus the matrix Y is equal to 5, 2, 1 and 3. So now what I'm going to do is I'm going to shift this matrix to the other side for subtraction. So Y becomes equal to 5, 2, 1, 3 minus 3, negative 4, negative 2 and 5. Okay. So now if I combine the elements, I get 5 minus 3, then 2 minus of minus 4, 1 minus of minus 2 and 3 minus 5, and therefore the matrix Y is equal to 5 minus 3 is 2, 2 plus 4 is 6, 1 plus 2 is 3 and 3 minus 5 is minus 2. Therefore, using the techniques of simultaneous equation, I was able to find my matrix X and Y. Now somebody might think of, what if the coefficients do not match? Like over here, adding the two matrices was fine because their coefficients matched. But what if the coefficients do not match? In that case, you can still use the normal concepts of simultaneous equations. That is, multiply the whole equation by a certain value, and then you can add and subtract your matrices to get rid of one of them, and then find the second matrix. So let me give you an example. I will show you how to do this using an example. But let me pause for a few minutes so that you can take a look at this particular problem. So let's consider this question now, where the coefficients of X and Y don't match. So my first equation is 2x plus 3y. 2x plus 3y is equal to 2340. And my second equation is 3x plus 2y is equal to negative 2, 2, 5 and negative 5. So now what I'm going to do is I'm going to decide which matrix to eliminate. So the strategy is going to remain very similar to the method of solving simultaneous equations using the elimination method. So let me choose to eliminate the set Y. So if I want to eliminate set Y or matrix Y, I have to make their coefficients equal. So it means let me multiply the first equation by 2. So what I get is 4x plus 6y is equal to twice of this matrix, that's 4, 6, 8 and 0. And let me take the second matrix and multiply it by 3. So what I get is 9x plus 6y is equal to, let's multiply the right hand side also by 3. So I get negative 6, positive 6, 15 and negative 15. And now I can subtract these two. So when I say that I want to subtract, please be careful. It will involve subtraction of matrices. So when I subtract, what I'm going to get is 4x minus 9x will be, okay, let's do one thing. Let us shift this to the right hand side. Just a minute. Yeah, I think this is much better now. So 4x minus 9x is going to be minus 5x, and 6y minus 6y cancels. This equals, I have to subtract the two matrices, 4, 6, 8, 0 minus negative 6, 6, 15 and negative 15, right? So now I have to subtract this. When I subtract, I get 4 minus of minus 6, which is 10, 6 minus 6, which is 0, 8 minus 15 is minus 7, and 0 minus of minus 15 is plus 15. So the equation that I get is negative 5x equals 10, 0, negative 7, 15. Okay, so now what I will do is, I will solve for x. So x is therefore equal to, negative 5 should go down to division. So what I will do is, x is therefore equal to negative 1 by 5 times this particular matrix. So let's write it down. Negative 1/5 of the given matrix, which is 10, 0, negative 7 and 15. And let's write its value. Negative 1/5 of 10 is negative 2. Negative 1/5 of 0 is 0. Negative 1/5 of minus 7 is 7 by 5. And negative 1/5 of 15 is negative 3. So this is how I reach the value of x. Now I am going to substitute this value of x to get the value of y. So let's substitute x in, say, the first equation. So 2 times x is going to be 2 times negative 2, 0, 7 by 5 and negative 3. This is the value, this is the matrix x, plus 3y equals 2, 3, 4 and 0. So I get 2 times negative 2 is negative 4, 0, 14 by 5 and negative 6 plus 3y is equal to 2, 3, 4, 0. So now I can find the value of y. Let me now shift this matrix to the other side. So let's shift this entire thing to the right side so that we gain some space for problem solving. Okay. So now I have, and let's make a nice box here to work. Okay, so what we now get is 3y is equal to 2, 3, 4, 0 minus negative 4, 0, 14 by 5 and negative 6. So 3y is equal to, let us subtract now. 2 minus of minus 4 is 2 plus 4, which is 6. 3 minus 0 is 3. 4 minus 14 by 5. So if you actually evaluate 4 minus 14 by 5, you will have to take the LCM. That's going to be 20 minus 14 is 6 by 5. So this is 6 by 5. And 0 minus of minus 6 is positive 6. And therefore, y will be equal to 1/3 of this matrix, 6, 3, 6 by 5 and 6, which is equal to 1/3 of 6 is 2, 1, 2 by 5 and 2, right? So this is the matrix Y. So you would have observed that we use the same concepts of solving simultaneous linear equations by elimination in this particular problem also, and the method remains exactly the same. So let me pause for a few seconds so that you can take a look at this, and then we will move on. Okay, moving on to the next question. So this is the last question in this particular segment. We have to find the matrix M so that this equation holds true. So what I'm going to do is, I see that every matrix is getting multiplied by a scalar. So let us simplify that part first. 3 times 2 is 6 and 3 times 3 is 9. 3 times negative 4 is negative 12 and 3 times 5 is 15. Plus 5m is equal to 4 times 9 is 36, 28, 0 and 40. That is when I multiply 4 with all elements. Plus 0, 0, 9, 0. Now I can add the matrices on the right hand side, and I can shift this matrix for subtraction. So 5m becomes equal to 36, 28, 0, 40 plus 0, 0, 9, 0 minus 6, negative 12, 9 and 15. Okay. So let's add and subtract the corresponding elements. So 36 plus 0 minus 6. Then 28 plus 0 minus of minus 12. Be careful with the signs. 0 plus 9 minus 9. And 40 plus 0 minus 15. Right. This is my matrix 5m. And of course I need to shift the 5 to the other side later. So therefore 5m is equal to, let's evaluate now, 36 minus 6 is 30 and 28 plus 12 is 40. This is 0 and 40 minus 15 is 25. So now that 5m is equal to 30, 40 and 0, 25. Let us now evaluate the matrix M. M is 1/5 of 30, 40, 0, 25. And finding 1/5 of each element, 1/5 of 30 is 6, 1/5 of 0 is 0, 1/5 of 40 is 8 and 1/5 of 25 is 5. And therefore the matrix M is equal to 6805. So this is the answer. Again, pausing for a couple of minutes. And this is going to be the last question. So we will solve a few more matrix related questions in our next segment.